Hello everyone. Welcome to the lecture series of data structures and algorithm. And in today's lecture, we'll be learning about the introduction of data structures and the importance of data structures. Why do you think that we are studying this subject? What is the importance of data structures? So there's all things we are going to study in this particular lecture. So the first thing is, we are studying data structure, and specifically this is an most important subject of computer science. So when dealing with data structures, we obviously have a computer with us. So what is a computer? So computer is an electronic machine which is used for data preprocessing and manipulation. So you are given some set of data on which you have to process and manipulate the results. For that, you have to store your particular data on which you want to work in some memory. And when programmer collects such in types of data for preprocessing, he would require to store all them in computer's main memory. So when you have to work on some program, that program has to be available in the main memory. And there comes the need of the storage, right? And data structure means structuring the data in different formats, right? So this particular line is very important to understand. In order to make computer work, we need to know representation of data in computer. So first of all, we should really understand how the data is being represented in computer. And we also know that in the language that we are using is high level language, and we are converting that high level language into machine language. And what is machine language? Your computer understands the language of zeros and one. It understands everything in binary notation, right? So, what are the different things that we need to do when we are using our computer? Let's say, first thing is accessing of data. So many things are available on your computer. So, from time to time, what we need is we have to search some data. For that, we should also know where to store the data and which particular format we need to store our data, right? And then how to solve problems step by step. Then for doing the task, we use data structure. So there are different tasks that we do from day to day life, and for all of it we need data structures, right? Now, what is data structure? So data structure is a specialized form for organizing and storing data. So whatever data we are having, we have to organize it in some order and store it, right? So if I talk about a library, there also you have what you have to store the books, right? But can you arrange the books in any particular order? No, right? So if you do it, what will happen? It will be very difficult for you to search some specific book, and it may happen that to search a single book, let's say there are 1 lakh books in your library, and you have to search a particular book, and if the books are not arranged in some specific order and they are randomly located in the shelves, then it will take around how many days, you don't know. It will take around many days to find out that particular book, right? So that is why this particular example, let me explain you the example in detail so that you understand the relevance of data structure. So in a library, when you go there, you have different sections. So let's say if I talk about one particular section, that is engineering section. So in engineering section, you are going to see all the books of engineering. In science, you are going to see all the books of science. In mathematics section, you will see the books of maths. And similarly in biological section, you will be seeing all the books related to biology, and similarly in law, commerce, and various other subjects. So in library, every stream has been divided into different sections. And specifically, let's say if I go to engineering, then that engineering stream is again divided into several sub sections, right? So in engineering, we have computer science in engineering, we have electronics engineering, electrical engineering, mechanical engineering, civil engineering, biomedical engineering. Again, there will be different, under that engineering section, there will be again different sections of the different branches of engineering. And then specifically, if I talk about computer science and engineering also, computer science and engineering also, there will be again subsections, right? So it is forming a hierarchy. Initially, we have books, and in books, we are having different subjects, right? Engineering, then we have science, then we have maths, biology, commerce, law. So there on the first level we have the different subjects. Again, in those subjects, I'm dividing, let's say, engineering into different fields of engineering. That engineering is having again so many nodes of right? The different branches of engineering, and specifically in coming to computer science and engineering, you know very well there are books related to programming, then there are books related to, let's say, data science, machine learning, books related to networking, books related to, you can say, Linux, books related to data structures. Again, there are several subsections, right? In this way only it will be easy for the user to get the book. And if you do so, what you have to do, let's say you have to find out the book of data structure and algorithm. Let's say you want to search the book Corman, right? What you will do, or you can want to search the book Tenenbaum, you will enter the library, you will directly go to the engineering section. From that engineering section you will go to the computer science section, and from that computer science section you will be going to data structure. So it took, just fraction of seconds to go to that particular column. But it may happen that again in data structure there are so many books, so it may take couple of minutes to find out that particular book. Again, if the books are arranged in some sorted order, then you can easily find out that book. So this is a real life example that we see from our day to day life. Another example, beautiful example of data structure is your dictionary. If your words are arranged in any order, then it will take, even it will take your whole life to search a specific word, because there are millions of words stored in a library. But when you want to store a word, if you want to search a word, let's say data, so in your dictionary all the words are sorted from alphabetical order A to Z. So if you want to search the word data, you will directly go to D, and from that D again you will go to the next word, next letter, that is A. Now DA, and in DA when you start searching, after some time you will find a word data. Then in first you will start D with A, then T. In this way, alphabetically one by one you can access the particular element within some time, within some fraction of seconds. So these library, or you can library management system, or you can say your dictionary, are the real life examples to understand what is the importance of data structure. Similarly, in your computer also, you have to store your data in such a way that it can be easily, searched by the user. For that, we have different data structures that we will understand. Now, I think the essence of data structure, or the importance of data structure, is being built in your mind. Now, we basically in data structure is a collection of data values, and we have the relationship among them, and we have different operations to access that particular data. Now, coming to what are the different advantages of data structure. So, data structure helps us to, store abundant amount of data on the hard disk. So, whatever may be your requirement, accordingly you can purchase your hard disk, or whatever system that suits your requirement can be purchased by you, right? So that it serves your purpose. Then it provides means for management of large data such as database, and are necessary for design of efficient algorithms. So to do whatever thing we need memory, right? And it also helps us to safely store our data. So with the help of our laptops that we are having, we can our data safely on the computer by putting the password and everything password restricted, so that no one can easily take it away. And it also helps us to, easily process the data. Now there are different types of data structures available, and we should understand which particular data structure we should use for meeting our demand, and that you will understand by the time, let's say. Now the next thing is disadvantages of data structure. What are the different disadvantages? One is only advanced users can make changes to data structures. One thing is, when you have defined your data structure, every user is not given the privilege to do changes into that. So uh, accordingly, the permission is set who can use it and who can do modification into that, right? And for problem involving data structure, we need experts help, right? Now coming to the different types of data structures. So what is data structure? Basically, whatever thing, entity that can store something. So we know that when we have learned C programming also, we had these data types, integer, which was used to store 2 byte of information, then float 4 byte of information, right? We were not having Boolean there in C programming, but yeah, it is available in other programming languages like Python. And then we had char, which can store a character. So all these particular data types were used to store some sort of information. And when we used to store integer, let's say we have to store something without decimal part, we used to store it in integer variable. And if we want to store something of having decimal values, then we used to use this particular data type float. Boolean is used to store true and false values, and then character is particularly used for strings, right? So it depends on the user's choice what particular data structure they have to use. Accordingly, they can use it, right? And these are called as primitive data structures, right? And then we also have some complex data structure which are used to store large and connected data. So they are storing only a bit of information. Here we can store only 2 byte of information. In float we can store 4 byte, and boolean is not available here. So char we are storing 1 byte of information, right? So we have abstract data structures that can store huge information. So we have array in which we can have collection of elements being stored with the name of the given array, and by writing the index we can access any particular element that we want to access. Similarly, stack is also used to store collection of elements. In similarly in queue, linked list, tree and graph, and all these kind of data structures we can store huge collection of data, right? Now this is the given flow chart for the different data structures that we will be studying throughout our course. So data structure is basically categorized into primitive and non-primitive. And in primitive, as we have studied in the previous slide also, if we have integer with us, then which is used to store values without having decimal. Floating point, which is used to store decimal values. Then we have character, and we have pointer with us, right? And in non-primitive, we have array, and then we have list. List is again divided into linear list and non-linear list. So in linear list, which gives us a sequential representation of data, that is we have stack and we have queue. And in non-linear we have graph and tree. They are non-linear in structure. All we will understand when we will be studying all these particular data structures in detail. And then we have file. Again, file is stored in hierarchical structure, right? So then what are the different primitive data types? So these particular primitive data types, that is integer, float, and character, are available in most of the programming languages, whether it is your C programming or it is C++ or Python or Java. It is available in most of the languages, right? And integer is used to store whole numbers, or you can say values without fraction. Float is used to store values which are having fractional numbers or decimal numbers. And similarly, character is used to store character values. Then in non-primitive data types, we have array. And what is array? Array is collection of homogeneous data, right? And in this particular data structure, you can insert any element at any particular location. And similarly, you can delete any particular element from the array. So there is no fixed order. You can delete any element from wherever location you want, and you can insert any element at wherever location you want. So there is no fixed order. You can insert or delete any element at particular any order, right? And coming to stack, but here the condition is the data should be of similar data type. If we are storing integer, then everything should be integer. If we are storing float, then all the elements will be in float data type, right? Now coming to stack. So this is the next non-primitive data structure. So here stack is stored in LIFO manner. LIFO means last in first out. So the element that has been inserted into the last will be deleted first, and the element which was inserted first will be deleted in the last, right? And we will also discuss the various examples related to stack, queue in the coming slides. Now we have queue, and in queue, what is a queue? Queue is basically, based on the principle of FIFO. FIFO is first in, first out. So whatever we have entered first can be removed first, will be removed first, and whatever we have inserted in the last will be removed at the last, right? Then we have linked list. Linked list is basically collection of node. Here also you can insert and delete the data in any order. Now see, in stack and queue, we are not having any order. We cannot delete or insert the element in any given order. But here in stack and queue, we have a fixed order that is based on the principle of LIFO and FIFO. But in array, we can have any order. Similarly, in linked list also, it is a collection of nodes where the node is having two parts. First is your information, and the next part is dealing with the address of the next node. And here also you can insert any data or delete any data in any order that you want, right? Then we have tree, uh, and it stores it stores the given data into non-linear form, and it forms the shape of a tree, or you can say it also looks like a hierarchical tree, where the topmost node is called as the root, and the other nodes are called as sub nodes, and the sub nodes are basically the internal nodes and the leaf nodes that we will better understand when we will be understanding tree in detail, right? Now, what are the different operations on data structure? So the first operation is create operation, right? So this can be done with the help of declaring the statement. So when you declare, let's say if you write int space x, so a variable x is being created in the memory whose data type is integer, and it will be allocated some space with some given address. So we have to define the particular variables with its data type, and after doing that, that particular variable is being created in the memory and some space is being allocated to the given variable according to the data type, right? And also we can create during compile time or runtime. So you can, create the variables at the runtime, or you can create it at the compile time. It again depends on your programming requirement, right? Then we have the another operation, that is delete operation. So this particular operation helps us in, destroying that memory space that has been created with the help of this create, right? So when you are using create operation, this helps us in creating that particular data structure for our requirement, and delete is used to remove that space so that it can be used by other variables or other requirements, right? Then we have selection operation. This selection operation deals with accessing particular data within a data structure. So if I have an array of 10 elements and I want to specifically, access the fifth element, so that can be accessed with the help of this. So basically selection is you can particularly select any particular data available in the given collection of list, right? Then we have updation. Updation means we already have some data in the particular file or folder or variables, and if we want to modify it, we can do the same. So initially if I've stored something in a variable, let's say x is equal to 10, and in the next line I'm writing x is equal to 15, so that 10 value is overwritten by the 15 value and it has been modified, right? Now coming to the searching operation. Searching operation means you are given a data set, and from that you have to find out whether the element that you want to search is available in the list or not, right? So that can be also done with the help of linear search and binary search that we'll be understanding in the coming lectures. Then we have the operation sorting, and we all know by the name and meaning or itself that sorting means you are arranging the data in some fixed order. So and that order can be arranged in ascending order or it can be arranged in descending order, right? And for sorting also we have several algorithms like bubble sort, quick sort, merge sort, and that also we will be understanding in detail when we will be going through the different lectures that will be coming in the future, right? We have merging operation. So in merging operation, we are combining the data items of two different sorted lists into a single sorted list. So let's say if I have two lists and I have to merge the data. So simply by merging them, we get a new list which is having a sorted list, right, of the both data structures that we used. Then we have splitting, and in splitting what we do is we divide the given list into two or three, whatever is your partitioning rate, whether you want to delete it into two parts or in three parts or in four parts, again dependent on it. And with the help of this we create multiple lists, right? Then we have traversal, and traversal is a process of visiting each and every node of a list. So again, if I talk about a graph or tree, there we have to search something. For that we have to traverse each and every node, and that will be in case of tree we will be learning in order, pre-order and post order, and in graph we'll be having the traversal technique, BFS and GFS, right? So this was all about the introductory section of data structures. I hope you liked it. So stay tuned for the coming lectures.